So I'll be talking about debugging in R today. And all of this content was content that I taught in a workshop at our studio conference along with Jenny Bryan. The workshop was called What They Forgot to Teach You About R, and it had this debugging section, but also had a bunch of different things like using Git and GitHub, basically everything outside of R, the language that we think people sort of sometimes miss out on in traditional courses for learning R. And so as a result of that, all of those materials are also online, and there's also a website, whattheyforgot.org. And in some of the links here, you'll see WTF as part of the link. And so that's where that's coming from. That's why those are there. So just introducing myself, my name is Jim Hester. I'm a software engineer at RStudio, and I primarily work on the tidyverse set of packages, developing them. And as I mentioned, the slides are this bit.ly link, bit.ly and rdebugging. Oh, and I should also, I guess the other thing is you shouldn't really need to have any packages installed on your system in order to follow along with this, other than for the exercises, we use this package to pull down the actual files you're going to be working with. So you might want to install the use this package if you don't already have it. And if you have the DevTools package, you should have the use this package already. It's one of the parts of DevTools. So I mentioned that there was a website in conjunction with this workshop, and that website is whattheyforgot.org. So all of the material that I'm going to be talking about in these slides is available in long form on that website. So that's a really good resource for you to look at. Later on, you can easily go back and cross-reference what we talked about today. So why should you debug? Why do we need to learn how to debug, and why are those skills useful? So mainly because computers don't always do what we expect them to. So we all probably spend a lot of our hours sitting at a computer trying to make the lights work in a specific pattern. And what happens when those lights aren't working in the pattern? How do we most quickly get them flashing in the way we want? So usually the reason you're starting to debug is you run into some error that you don't quite understand. Maybe you have an error like this, subscript out of bounds, which tells you sort of what the problem is, but not why, how, what, or where, or anything like that. So you have the what went wrong, but you don't have any of the additional context. So really debugging is about gathering this additional context. So the first step in debugging is to Google your error message and Google the exact error message. So maybe use like quotes, double quotes in your Google search and get exactly the error message that you saw on the console. And that really actually works really well. R is used by millions of people today, so it's pretty likely that someone else has run into this before and may have an easy fix. And I'm sure all of you probably already do that. But I think it's really important to be good at doing those Google searches, and don't discount that as a valid way to solve problems. I think it's a really useful way. Secondly, you can use keyword search on sites such as the RStudio community site or on Stack Overflow. So you can just go to the community site and search, and put your error message in that. Or on Stack Overflow, you can use a search with a tag. So if you use this bracket syntax on Stack Overflow with the R tag, that will restrict results just to R results, and usually that's a way to narrow down the responses you get. So those are all sort of things you can do outside of R itself. So what tools do you have actually in R? So these are basically what we're going to be talking about today. And I'll go through them sort of in top down. So the first line of defense is traceback, which tells you where your error occurred. Print, cat, and str sort of give you more context around objects, and I think they're really useful tools for debugging. the browser function puts you into an interactive browser, and that's actually sort of what people traditionally think of when they're actually doing real debugging. They're thinking about this interactive debugger, and then some more advanced tools like the debug function, trace, and recover. So the first function, I think one that is really often overlooked by a lot of people, is traceback. So what this function does is, after you've received an error, so let's say you define two functions, f and g, and then call g with some input that it wasn't expecting. So in this case, g is expecting numeric input, or actually f is expecting numeric input, and g, the value you're passing to g is a character. So you get an error that a non-new argument, and you've, I'm sure, seen this error, non-numeric argument to binary operator, which is a correct error, but not very useful in most cases. So how do you figure out where that error is actually occurring? You can use the traceback function for that. So if you call traceback immediately after the error, it will print this stack trace, which is the one in the lines below the traceback, which tells you which function actually threw the error. So in this case, you're calling the g function, but the error is actually coming from the f function. And okay, so one thing that I end up often doing is misspelling traceback. The problem with this is when you do this, you now get an error in the call to traceback, so you no longer have your traceback, and you have to rerun your code to get the error and then do traceback again. So an easy solution to this is in your R profile, just create a new alias. So tb is equal to traceback, and then you can just use tb, the quote, the parentheses, and then you don't have this spelling issue. This happens to me like all the time, and I actually don't have TB in my R profile. I should use my own advice and do that. The other thing you can do is it's actually possible to have R do something by default on an error. So there's this options. You can set the error option to the traceback function. Then it will automatically print the traceback as soon as there's an error. The next function that is also maybe not so much overlooked as traceback, but is very useful, especially when you're debugging your own code, is just put print statements in there. And this is very easy. This is like the simplest way to debug something is, I don't know what's in there, let's print out the value and see what we get. So we can do that with our example here. And we can see that x has the value a here. And maybe that gives us an idea that we're getting a value we didn't necessarily expect. So the str function is very similar to print. So print is what you would get if you just print it, if you try to view an object on the R command line. That's what you get from the value of print. str is slightly different. It gives you the structure of the object. So often this also has the value. So in this case, it says chr and then our value, which is a. But the chr is giving you a hint that that's a character vector. And this str function is useful because it gives you this type information. So often errors in R happen because the type the function is expecting is different than the type that you're actually passing to the function. So using strs is very useful for that reason. The other reason it's useful is sometimes the output from print can be very long and really hard to read, especially if you have a really big like data frame or something like that. And that's better with things like tibbles, but often you're just working with raw data frames or very big vectors. And str truncates the output by default, so it's much easier for these big objects to look at the str representation. So now I'm going to show a demo of sort of using these tools in a toy example. And I should actually, I don't think I have our studio started. No, not RStudio 2. Oh, I think I deleted my example. Did I? Hold on, it should be in the trash. I forgot where I put it. Then I put it in here. Well, I can use a different example pretty easily. Yeah, that's fine. I can do an example with the one I was showing here. So we have two functions, f. Let me make this bigger. This is x plus 1, and g, which just calls f. And then if we call g with a, I'm going to source this.
Call it with something weird like a iris or something so that you get
all right, a more interesting, good idea.
Nice,
oh, that actually somehow works.
Oh, sorry, never mind.
That's interesting. I'm not actually sure how. Oh, I guess. What?
Why does the last column should be species? The last column is species.
Yeah, I guess it says it's not meaningful for. You get a warning.
Oh, it's a factor. That's why.
Yeah, it's a factor.
Yeah, okay. It's a factor.
This is actually an interesting idea, though. So, yeah, so this is a warning. Sometimes warnings actually should be errors, and how do you debug those? So we can talk about that too. But I will do that after this first.
Sorry.
But I think that's actually good because how to deal with warnings that you actually want to be errors is a useful thing to know. So yeah, so we pass the character, we get this error. How do we figure out where it is? So the first thing, like I said, is traceback. Is this big enough? Traceback. Which gives you a very interesting. Okay, so it's showing that I first call. You basically read this from bottom up. So I first called G, that called F, and then that's sort of indicating where it is in the document. And then often you want to do like print debugging, so I can use print and do that. I should comment this out. So then I can call G, and then we get the value of that print statement. str is similar idea. But yeah, let's try doing str with iris this time and see what it gives us. So
there's the answer.
Yeah. Yeah.
There it is.
There. Okay. So it's very similar. If you've used DeepLiar Glimpse, it's very similar to that for obvious reasons. And it's, like I said, it's useful for objects like data frames because it gives you sort of an overview of the whole thing. So you can see that it has 150 observations, so 5 variables, so you get the dimensions of the object. But also for each column, you get the type of the column. So we can see there's 4 columns of numeric, and then the species is a factor, which is why this doesn't error, because you can actually add factors. That's actually a good idea most of the time is, I guess, not, but there it is.
But
and then
it gives you NA. It's kind of a bad result, actually.
Yeah. So giving NA is really not useful. So let's say you don't like this behavior and you actually want to convert this warning to an error. The way that you do that, there's this global option in R to do different things with warnings. So by default, this is 0, I think, which means that warnings are deferred until the end. So you might have seen this where you run something, you get a bunch of warnings, and then once it's finished, R says there's like more than 50 warnings, and you get this huge like output. It's sometimes useful, but I find it's also often not what I want. I would much rather like see the warning sooner rather than later. So the first thing you can do, the first way to do that is set warn equals 1. And that will instead of waiting to deferring the warning printing until the end, that will print the warning as soon as it happens. In this case, I don't think it will be any different. Here, let me assign this to, because we only have one warning. But it's kind of, actually, you know what I could do? So if I assign this to a variable and then do str and then return it. So this is doing exactly the same thing, but I'm switching the order of when things happen, so you can see when the warning is actually happening. So if I run this again, the warning is now happening before I'm doing the str. But if I switch this option back to 0 and run it, then the warning happens at the end because those warnings are getting deferred until the end, until it returns back to the top level. The third setting you can use is warn equals 2. And in this case, basically warn equals 2 converts every warning, not just this warning, but every warning you could possibly get into an error instead. So it says, so this is now an error. And this is actually really useful if you're getting a warning and you want to use your regular debugging tools to figure out where that warning is coming from. You can switch it to an error and then treat it like an error. Use your similar debugging tools that we'll talk about as the night goes on. So I think that's a good tip. That's actually not in my slides, but maybe should be. Yes?
Could you rerun traceback?
Yeah. So okay, this is a good point because you'll get crazy traceback because of the way that R is converting the error to a warning. But yeah, so basically so FG and here is, well, so where would the error, so this stuff, all this is like the plumbing that R is using to convert the error to a warning. But everything below, I don't know, is that below or above? But everything else is actually useful. So this is the call that's causing the warning, and then this is showing like where the functions that are actually occurring, where it's actually occurring. So that's, I guess, something to keep in mind when you're doing this conversion, that you'll end up with this plumbing stuff that you might not need to worry about.
Okay, I didn't realize it's saying to add is the line in the file. Mine doesn't say active RStudio document, it just says add.
Oh, yeah, that might be that, yeah, I don't know if that's caused by an option I have set or something, but yeah, that's possible that this might not be there. Okay, back to the keynote. Okay, so that was just looking at print debugging basically, and exploring traceback. So the sort of step up from print debugging is using the browser, the interactive debugger, which you get to by using the browser function. Or one way to get to it is using the browser function. And what this does is basically puts you in a new prompt, very similar to the standard R prompt you're probably used to, where you can do things like list all the objects that are available with the ls function, print a specific object, or use str, or really actually you can use any R function in this prompt. It's very much analogous to your normal prompt. You just stopped at that location where you put the browser call. You can do some other things, so you can actually step through your code statement by statement. So using the N keyword, you can step through your code. You can use C to actually just continue execution without stopping. S will, if there's a function call, we'll step into the function calls. So this differs from using n, because n will only basically call the function, return the result, and go to the next function, whereas s will actually step into that new function. So depending on your case, sometimes using n is useful, sometimes using s is useful, it really depends. And then finally, f will, if you're in a particular function or loop, f will finish that function and put the debugger at the location where the function returns or the loop ends. There's a couple other commands that are, so where will actually basically print traceback in the debugger, so it will show you all of the calls that led you to where you're at currently. It's very similar to the output from traceback. And then Q, capital Q, will quit the debugger and put you back in the normal R terminal. So now we can use our same demo and show this. So, and actually, I'm going to turn off. Well, it's fine. I'm going to put a browser statement here in F. Source this. We'll do it with iris again. Okay, so this now puts you in a browser, and this works in RStudio, but it also works on the command line, basically the same way. And right now I'm just going to show you how you'd use it on the command line. I'm going to go into sort of the RStudio buttons that do similar things a little bit later. So the first thing to notice is that the prompt is slightly different. So now this is showing browse 1, which is indicating that you're in the interactive debugger rather than the normal R prompt. And you can do things like you call str. First, it's sometimes useful to see what objects are available. So you can, because actually where we are is right where this arrow is showing the browser statements. So it might be useful to see. I don't know why that was so slow. Hold on. Okay, so it might be useful to see what variables are available. In this case, there's only one variable in this function, so it's not very useful, but sometimes you're in a function you don't really know that well, or you're not exactly sure which arguments are there. So sometimes printing the objects is useful. Then you can use str and print to print those objects, so we can see that. And then if you wanted to go to the next line, you can use n without any parentheses, just it's a statement. So use n to move to the next line. You can see that the cursor moved down one. I can try using s here to step into the plus, but I'm not sure it will actually work. Oh, maybe it did. All right, it did. So we now into that plus statement, and we can step through this in the same way, checking various things, and then use F to finish this function call and go back.
You finished all of them.
It finished all of them, interestingly. Maybe because there was no other function. I don't know why. I'm not sure why that happened. But, oh, I know why, because we converted warnings to errors.
You hit the error there inside there.
Yeah, inside the browser, yeah. So let's turn this back. I think now it will S, now do F. Yes, and now we're back out.
Yep.
So now we can look at the value of Y. And
yeah, the number in the browser kind of shows you how deep you are in the call stack.
right, exactly, yeah. And then I guess Q, the other thing I showed, where we didn't show yet, but so where basically gives you the same traceback in a slightly different format than the traceback function would give you. And finally, Q is what you would do to quit out of the debugger and go back. It stops execution, right? It doesn't try to finish the rest of it, it just stops where you were and takes you back to the terminal. So that's the main parts of the interactive debugger. So now we can use these tools, and so this is online. So we actually have this code. So you can get it by going to calling this function, use _course, and then this URL, and it will download the files to your desktop. And you can open. There'll be three different files, all called 01 debugging, and then 3 different prefixes: Spartan, Comfy, and Jim. So Spartan has very little hints on how to fix the debugging, how to debug this. Comfy has sort of more hints in it, and Jim is actually like my solution. So if you are stuck and can't figure something out, then you can just look at the answer. And I'll actually run this myself. Well, I think I might have put it on the desktop already. Just to orient yourself. So if you, this isn't terribly big, I apologize, but basically there's a few different debugging exercises. This is all of the exercises we'll be doing today. And all of them have these 3 different files. So right now you can probably just open Spartan maybe. And if you look at this, there's basically 3 different functions. So if you open this file and then source it, and then run the get climates function, I'm in the wrong direction. So you have to be your working directory. So I think use course will actually do this for you, but if not, if you open the R project file, make sure your working directory is in that folder. And then, I guess I'll switch to this one. And then if you source it, source, and then run git projects, git planets, what is the, oh, git climates. Why did that not work? Well, I guess the first problem is that this is in the regular function. So there's 2 bugs in this. The first bug is that the file path is wrong, so they can change that here. And this is the bug you're supposed to be solving. So error in string split non-character argument. So I think we'll take like 5 or 10 minutes to work through using the tools we've talked about already. Where this bug is, so you basically see what the bug is, but not where, why, and how this is happening. So use your debugging tools, browser, print statements, traceback, to figure out what the bug is and how to fix it. And I can help people if they run into issues. All right, I think we'll stop here. And I'll take you through sort of how I would maybe do this. So you get this error. First thing I would do is trace back to see where it's happening. So we get our trace back here. We have a few more functions, so the trace back's a little more interesting. So we're first calling this get climate function, which is calling uniqueify. And then that's calling clean up here. And that is calling stir split in here. So the next thing that we could try, just calling print with this function. There's only one argument here, so we could just do that. call print, and then source this and run it. And this doesn't give you terribly useful, well, it does if you're very observant, but it doesn't give you terrible. It looks like basically like correct data. It looks like a string split should be able to handle this. So the next thing you could try is using str. And often I just forget using print altogether and just use str because I find it more useful. Here we see that this fact argument is actually a factor of 5 levels. And if we try to call stir split on any factor, we'll get the same error. So basically stir split doesn't work on factors. So that's really the cause of this error. So now that we have that, that doesn't tell us why this is happening though. So we have this error. So I guess one way to fix this is, well, we actually want a character, so we can just change that factor into a character, run that.
Not the best way to convert that.
CSV you can use.
It is not. Wait, did that not like source? We'll get to read CSV. My friend reads CSV. Okay, so that actually works in this case. That just converting it to an as character works, but really that's not really. That's like solving the symptom, not the cause. So if we go back a little bit, clean is here, and if we did an str here, actually maybe we'll use browser this time. So we can use browser here, source that, and then we can see our browser do strvec, and see it's still a factor here, so clearly there's some more issues before we get to clean, so it's clearly further back that we have to go. And then we can get to this original get class. So that was in Uniquify where we just were. So the only thing we did before that was called read CSV2. And if we just look at planets right after that, then we'll see this is reading our data, and then basically by default read.csv returns strings as factors by default, which often is not what you want. It's useful in some cases, but often is not. So one way to fix this is there's our strings as factors argument that will fix it. The other way is switch to a different function. So if you use the readr function, CSV2, that doesn't use factors by default, so that's another way to fix this. And we can try running that and just verify that it did fix the problem. And this actually is showing you also that, so another somewhat nice thing about all the readr functions is they give you this column specification that they have guessed from your data, so it's easy to see if the column types are what the types that you are expecting them to be. So we can see that all of the character columns were character types, were read as characters, and then the sort of numeric types were doubles. And maybe if you had something you thought was a numeric type is actually read as character, maybe you have to go and look at the data and see if there was something wrong with your data in that case. So that was all debugging tools that you can use on command line R. So there's also some tools built into RStudio. So the first, and like I was showing, you can use all the command line tools in RStudio just fine, but you can also use these additional tools. So the first of those is what's called a breakpoint. So and that's this little red dot to the left of of the line numbers. So if you click to that left of line numbers in any source file that you've read into RStudio, it will insert a breakpoint at that location. And this is exactly equivalent to putting a browser statement there, except you don't actually have to change your source code. You can just click in the IDE, and it really under the hood is putting a browser statement at that location. The other thing you can do is have it automatically open up a debug window whenever there's an error. So you can do that by going to the debug menu and then selecting the error inspector option. And that will take you into that debug prompt anytime there's an error, which is useful if you're working on a script and trying to debug the error. It cuts out one step. And then actually, when you're in this interactive debugger, RStudio has a few helpful buttons that correspond to those commands that we were using previously. So there's the next button, which corresponds to the end statement. The next button over is the step into button, which corresponds to the S. The next button over is for finishing. That corresponds to the F. And then the continue button corresponds to C. That just continues. And stop corresponds to a capital Q. So if you don't want to remember all of those single letter statements, you can use these buttons instead. And I guess I can just show those real quick. I'll just do a browser here. Well, let me change this back to read.csv2. And then first thing, so like I said, it was the debug menu on error and then click error inspector. And then this brings up this this dialog, which does a couple things. First, you can click show traceback and it will open up the traceback for that error, so you don't have to type and run the traceback function. And second, you can rerun with debug, and then that will actually rerun your code and then put you in this interactive debugger. And once you're in here, you can do all the things we were doing from the command line. You can use next to go to the next line, which in this case, there is no next line. So it just exited. You can step into, I don't know why that's exiting actually. But it's basically exactly the same as, and actually it does the same thing. So it just puts the S or the N in the statement. And then you can continue or stop. I guess one other thing to note is RStudio has this environment pane that's by default on the right-hand side. And that shows all of the values that are in whatever context you're currently in. So if you're in this interactive debugger, it shows you, like this is within stir split. Oh, actually that's sort of interesting. So it's actually putting me in the function call of the stir split function is where the debugger is. So you can see these other default arguments have been set. And sometimes looking at the environment pane is easier than like doing ls to see all the objects and then inspecting them individually. The environment pane is essentially the same, and you notice this output is actually the same thing you get from str, because actually what this environment pane is doing is for each object it's calling str on the object and putting the output there. So okay, so that's using the same tools that we have been using with inside RStudio. So now a couple more advanced functions. So recover is a lot like browser, but it lets you move up and down the call stack. So browser, you're basically stuck wherever you put the browser statement. But what happens if you want to inspect something higher up the call stack? Recover actually allows you to do this. And you use recover by setting an error option. So you don't call recover in your code. You set this error option, and then it puts you into the interactive debugger. So you just in the top, anytime when you're in the top level of your R session, you run options error equals recover, and then next time there's an error, it will put you in this recovery console. So just showing that with our same demo. So I'll set options error equals recover, and then run that. And so the first thing you get is a prompt asking you where in the call stack you want to go. So I'll say 3 in this case, and then you get put into interactive debugger at that location in the call stack. So in this location we have one variable vec. We can see it's a factor with 5 levels here. Then if I want to go to a different level, I push enter again to go out of that that interactive debugger, and then I can go to a different level. Let's say I want 2 now. So now I'm in this uniquify function. Am I in the uniquify function? And then I can look at what variables are there. Again, there's only vec in this case. But let's say I wanted to go into the first level, and here I get my planets object, which so I can see that like all of them are factor. All the characters are factors. So really, recover is sort of a helper for putting browser statements at every location in your call stack, and it's useful when you're not exactly sure where the error might be and you need to go up and down to investigate where it is. And then to get out of the recovery session, you just use Q from anywhere, and that quits you out. Okay, so we don't have tons of time, but I think it's worthwhile to go. I don't know if I should try to talk about any of these other things, or we should just do another exercise. What do people think? Would you rather try another exercise or talk about a couple more functions? Exercise? All right, we'll do that. Okay, so the second one, this is so they're all the ones starting with O2. I'll open it up. Okay, so this is actually a bug that occurred in real life. It was on the, I think, the Tibble repository. So, and it's related to an interaction with DeepLiar. So, basically, so there's this function in DeepLiar, NAIF, that given an x and a y, it will replace all of the NA values in x with the value in y. So let's say you want to replace all of your NAs with the value of 0. You can use this NAIF function to do that. So you put, and your object is called data. You call it as NAIF data, comma, 0, and that would replace all the NAs in data with zeros. So the issue was that it works fine if x is a data frame without date objects in it, but as soon as you put any column has a date object, then it fails. So first, why is this fail? So we can now use our debugging tools to try to figure out why this is failing, and well, first where it's failing, what function is actually causing the failure, and why is it failing. And reproducible example is here. You can use test, and then we can look at test. Test is just a data frame where it has three columns that are just characters. The date column actually doesn't even have any NAs in it. So this NAIF function, it actually it does the opposite of what I said. So it converts values into NA. So here we're trying to convert the strings that are just quotes into NA values. So we can call it by test the pipe operator and then NA if and quotes, and that ideally would convert these NA values, these quoted empty quotes, into NAs. And actually, I should show you it without. So if I take out that first column, so if I select everything but the A column, then this works fine. You get NAs for all the values. But as soon as you have a date, you get an error. And I still have options. You get, wow. Okay, so this is the error you would get. Error, character string is not a standard unambiguous format. And it's interesting because the date, if you notice, the date column didn't even have an NA. So what is happening? All right, I guess I'll show you how I would go about trying to figure this out. I actually don't remember what the answer is, so we can discover it together. So first thing that I always do is run traceback, so we can figure some things out. When you do this, you get like a very sort of confusing traceback. A lot of this ends up being the machinery that powers the pipe operator, the Magritte pipe operator. So often when I'm trying to debug an error that's using a piped expression, I convert it to a non-piped expression just to clear up this traceback. So if we do that, we just call NAF directly and then run traceback on that. The traceback is much cleaner in this case. So that helps a little bit. So we're calling NAF, and then this is looking at the assignment, the subset assignment operator in data frame, and that's calling a few other things, including the equals date. And then this is doing some sort of conversion to date. So the next thing we can do is use maybe options error equals recover, and run our code again, and then maybe jump down to one of these frames down here. So we'll jump to 8 maybe. We can look at first do ls. We see there's only one variable x, so we'll do str of x. So this is our double quotes with nothing in it, and we're trying to convert that to a date. So let's just run as date and then a character string with nothing in it. Well, I guess that actually gives us the same error that we're getting from this outer thing. The character string is not in a standard unambiguous format. And if we just run that from the top level, you'll see the same thing. That as date of this just gives you this error. Okay, so that's sort of interesting. So now if we actually, the other thing that I find is very useful when debugging things is to actually look at the code of the functions you're calling. And R is really great for this because all you have to do to look at the code of a function is to print that function. So if I print this NAIF function, it checks the length of x and y to make sure they're the same. And that code is working fine, so we don't actually have to worry about that at all. The next thing it does is for all of the values in x, checks if they're equal to y and then set them to NA. So let's try just looking at this x equals n, x equals y. So x in this case is our test data frame. So we just do test equals the quotes. That should basically be equivalent to what's being called in here. And we actually end up getting the same error. The reason is that is again because we're trying to convert this double quotes into NA. So it's actually not necessarily with problem with the X. It's really more of a problem with comparing it to the Y, because you can't have a date that is the string the empty string it can't be converted to a date. It doesn't make any sense.
The equality operator is calling a method there. You can see it
Right.
down below.
Exactly. Yeah.
And that
So
method is converting. It's the
yeah.
method
So
there.
this date
You can look at that function.
function. So yeah, let's look at that now. I guess that's a good idea. So let's look at this.
So that dot there means it's an S3 method on the. Yeah. So how to look at this?
So
Yeah,
well,
put it in a backtick.
I have a package for this. I think this will work. I don't know why that didn't work. Oh, I know why. So if I just look at all
the methods, I guess. Okay.
and then luberdate defines this date method maybe. Although that doesn't, I don't even know if it's calling this method. I don't think it is. But regardless, it might be.
Yeah, it's calling that method.
Yeah, so if we
It's
look
doing
at,
the conversion as POSIX CT right there.
yeah,
Yeah.
right here.
Without a format.
Sure, that's fair.
Yeah.
Yeah, right. So right, so so basically our issue is that. And I guess the reason this issue is happening is this NAF function is not really designed to be used with data frames on the left-hand side. It's designed to be called on each column. So like,
The same error would occur if you call
I
it
guess
the first
so.
column.
You're right.
Yeah.
You're right.
It's just not designed to work with
It's
dates.
just not designed to work with. Yeah, you can't have like an empty string as a date. So you could
Right,
call.
it assumes that the types are.
Are congruent. Yeah. So you could. So there's a couple things you can do. You could call this. So there's a DeepLiar function. That will call mutate if, I think, mutate if, and then so basically this gives you, it has three functions, the input, a predicate function, which basically just returns a true or a false, depending on if you want to use that. The third function, if you want to call basically it returns true or false for each column and if it's true, then it calls the function. If it's not, it doesn't do anything. So we can, for our predicate function, we can say inherits date. And then call our NAF function. I'm not sure if this will work. We might have to use another. Yeah, that didn't work. Ooh, that's. So hold on, let me just first. Turn off the recovery console. Okay, so that gives us the same error. But maybe this is not returning what I was expecting it to. That's true. Oh, it's doing the opposite of what I want. Yeah, sorry, that was dumb. Okay, yeah, alright, now it works.
Yeah.
So basically, we're checking if it's a date, and if it's not a date, then we want to call this NAF function. And maybe this is more clear. I don't know if it's more clear or not to do it like this, but that would work as well. And then yeah, we're only calling the NAF on those columns that aren't dates, and then that works fine. So so that's sort of a more real world case, that a little more hairy case of how to work around these types of problems and use the tools. Yes?
I'm a little surprised it doesn't convert it, because if you concatenate an empty string onto like a date vector, it converts it to NA. I assume it's going through a similar conversion process.
Oh, I see. So if you
If you do the Libra date
if you
today,
do like
C, Libra date today.
Yeah, but if you
do like
sys dot
sysdate,
and then the equality operator will try to convert the
if I just do like today, sys, what is it, sys today?
date, sys.
I know, but I wanted to actually, well then I
Yeah,
have to like,
that's it. You could just open close and it'll give you today, right?
would it?
Yeah.
Are you
of course.
sure?
Yeah.
Oh yeah. Hmm. I
And
think
then
I
if you
always,
concatenate that with C with a
so you're saying if I do this, then yeah, it gives me NA.
smart enough to handle it.
But this does not.
Yeah, it doesn't know, and equality doesn't work
Yeah.
there either, even in base.
I think this is actually like a bug in C actually more than, because it's like converting them both to char. Actually, I think these are getting converted to. Are these getting converted? No, they are still dates.
Yeah,
Yeah.
It's trying to convert the.
It's trying to convert that into a date, but yeah,
that's
I guess
that's a good.
it's definitely
inconsistency.
an interesting
I guess
inconsistency.
I like that.
That you like that behavior better. Yeah, you're probably right that this is. Yeah. But yeah, that's interesting.
That's an interesting
Yeah,
inconsistency.
yeah. So,
So what is if? What is it? What is that weird function called? If.
mutate if?
No, NA.
Oh,
if.
NAF.
What is NA if? It assumes true or false, but missing is not true, neither true nor false. Does it handle the ternary logic? Or
Oh, that's a good question. I don't know.
you could just put an NA, right?
Can I just do like NA?
Yeah.
It returns. Oh, so yeah, if it's already NA, it just leaves it, I guess.
Okay, so it works.
Yeah.
Yeah. Oh no. Yeah.
Right, because if this was something else, if this was like
Yeah.
A, then it should be NA, NA, yeah. Okay. So I don't know if we'll go through all of this because we're already an hour and 20 minutes in, but a couple other things that are sort of at least useful to mention. So all the tools we've talked about today are really work well when you're working with your own code. Sometimes the error is in someone else's code, maybe it's in another package or in BaseR, and it's sometimes useful to debug that code as well. So one way to do that is because R is an open source language and all of the packages on CRAN are open source as well. One easy way to do it is just download the source of the package and then use like DevTools load all to load the package, or use source for the specific R file that the function lives in, and then use all of the same debugging tools that we've talked about today on that code directly, just like you would with your own scripts. Another way is to use the recovery console that we talked about, so you can set that options error equals recover, and then use that to go into all of the call stacks, even if the function isn't in your code. Another way is to use debug. So the debug function puts a browser statement at the top of any function you want in R. So you can use this on BaseR functions, on package functions, any function in R basically. If you call debug and the function name, it will put a browser statement when that function is called. And there's another function related to debug called debug once that will put that browser statement, do exactly the same thing, but only do it once. So if there's a function that's called repeatedly over and over, and you only want it to debug it for one time, that's useful, because the debug function puts that browser statement there until you call undebug on it. And then finally, there's a function called trace, which is pretty special purpose, I'd say, but it lets you insert well, it does a couple things actually. So if you just call it with a function name, it puts a trace message at that function. So every time the function is called, it just prints a message saying that the execution got to there, which is sometimes useful. The other thing it can do, and you can actually put that trace message anywhere in the function body. You can specify where you want to put it in the call to trace. And the other thing you can do with trace is you can actually put any expression inside a function's body. So you can put like a browser statement inside a function's body with trace. So it's a little more powerful than debug because you can specify exactly where you want to put the browser statement, or even put other code in there. But it's fairly special purpose. And how you would use these is, like I said, just put the function body or the function name, you pass the function to the debug function call, and it would put the debug statement in that function call. And this works for exported functions like the ggplot function and ggplot2, but also for unexported functions, which is the triple dots. You can use debug in that on exported functions as well. And then you can use undebug to remove the debug. And then trace, like I said, you can put a trace by default. If you just give it a function, it prints this trace message, but you can also put other things, like you can, so in the second case I'm putting a call to browser in the print method, in the print function. And then you can also put more complicated things, so this is putting this complicated conditional and then a cat message inside this other function. And you can actually, and it's fairly advanced, and you can put this all over anywhere in the function basically. So it's pretty, it's fairly rare occurrence that I'll ever end up having to use this. Usually I fall back on most of the approaches we talked about today, but it's useful to know about at least. And the third exercise, which we don't need to do today, is using the trace function to insert a function, to modify another function, like a nested function call, and insert a browser statement to find an error. So if you're really interested in how the trace function works and want to look at that, it's there for you. And I guess that's all of the exercises I had.
Thanks. Yeah.